Imagine if we could find a way to visually represent all the different keys and how they are related to each other. We could find which keys were similar, which keys were further away from each other, and find out which sharps and flats were in each key. We could even use this representation as a map to find our route between different keys. Luckily for us, someone has already done just that. The Greek philosopher Pythagoras, in fact, he of the triangle fame. Maybe if Pythagoras was around today, rather than calling him a philosopher, we might call him a mathematician. You may ask what mathematics has got to do with music. Well, the answer is quite a lot actually. Sound is a very mathematical phenomenon. A violin string vibrates as it is bowed. As it vibrates, the string generates pressure changes in the air which our ears pick up and interpret as sound. If the violinist were to play the note A above middle C, the string would vibrate at 440 times per second. If you were to play the A an octave above that, the string vibrates at 880 times per second, precisely twice the number of vibrations per second as it did before. Another octave above that, and the string vibrates at 1760 vibrations per second, again twice the number of vibrations per second as it did on the previous A, and so on. Therefore, it's not surprising that someone with a mathematical mind like Pythagoras might think of turning his hand to music as well. Having had such success with triangles, when Pythagoras turned his attention to music, he decided that a circle might be the best shape to use. This circle became known as the circle of fifths. If you count the number of semitones in an octave, you'll find that there are 12 in all. Semitones includes all the black notes on the piano too. What Pythagoras did was to lay these 12 notes around the circle like a clock in a special order. Pythagoras didn't actually call them notes like the notes we know today. He worked with numbers. What we now call C, he called 0, and divided his circle into 1,200 pieces, or cents. Therefore, each of the 12 positions on his circle is 100 cents further round the circle from the previous halftone. This division of semitones and the creation of the circle of fifths lies at the very foundation of Western music theory. Because the circle of fifths acts as a sort of roadmap for Western music, it is incredibly useful to refer to when trying to work out things like what key you are in. If you're in a major key, it helps you find the relative minor key and vice versa. It tells you what chords are available in which key. It helps you to transpose your music into a different key and move between keys within a song. The reason it's called the circle of fifths is because of the way it's laid out. As you move around the circle in a clockwise direction, the next note you encounter will be a fifth above the note before it. So for example, starting at the 12 o'clock position we have C, move around to the 1 o'clock position and we find G. In the key of C, G is the fifth note of the scale. Move around again to the 2 o'clock position and we find D. Again, D is the fifth note of the G major scale. A more in-depth explanation of how the different scales work and how to find the different degrees of each scale like the fifth can be found in the podcast extra. If I play all 12 tones of the circle on the piano, you can hear the melodic progression. C, G, D, A, E, B, F sharp, D flat, A flat, E flat, B flat, F, and finally back to C. So how does the circle of fifths help us find out what key we're in? The key of C has no sharps or flats in it. Notice how it is at the 12 o'clock position, or the 0 position. The key of G has one sharp in it. Notice how G is at the 1 o'clock position. The key of D has 2 sharps in it. Notice how the key of D is at the 2 o'clock position, and so on, all the way around the circle to the key of C sharp at the 7 o'clock position, with 7 sharps in the key signature. I'm going to stop there just for the moment, and now have a look at the keys with flats in their key signatures. If we go back to C at our 0 position, and now instead of going clockwise around the circle, we go anti-clockwise, the key of F has 1 flat in its key signature. Moving another step anti-clockwise, the key of B flat has 2 flats in it. Another step, and E flat has 3 flats in it, and so on. Just as when we were going clockwise around the circle, assigning key signatures with sharps in them, we stopped at the 7 o'clock position. If we do the mirror of this now with our flats, continuing to move anti-clockwise around the circle, we find that we will stop at the 5 o'clock position. This means that 3 keys at the bottom of the circle can be written with 2 different key signatures, either made out of flats or sharps, but still sound the same. It all depends on what we want to call our key. C sharp and D flat, for example, are actually the same note. However, to keep things simple, if we say that we are in the key of C sharp, then we will tend to put sharps in the key signature, and if we say that we are in the key of D flat, we will tend to put flats in our key signature. So the first thing the circle of fifths tells you is how many sharps or flats are in the key signature you want your song to be in. But that's only half the story. Say you wanted your song to be in the key of E major. We know from E's position on the circle at 4 o'clock that there are 4 sharps in the key signature. But which 4 notes are sharpened? To find out, we simply start at the 11 o'clock position and count round the circle in a clockwise direction, writing down each note we encounter until we have the number of notes we know are sharpened in the key signature. So the key of E major has 4 sharps, and they are F sharp, C sharp, G sharp, and D sharp. That's all well and good for keys containing sharps in their key signatures, but what about flats? Well, the circle is symmetrical, so we just work backwards. Say you want to write your song in A flat major. If we start at C, to get to A flat, we have to move anti-clockwise by 4 steps, so we know that A flat has 4 flats in its key signature. Which notes are flattened? Well, this time we start not at the 11 o'clock position, but at the 5 o'clock position with B. So counting around 4 flats from B, we have B flat, E flat, A flat, and D flat. However, for us as songwriters, the usefulness of the circle doesn't stop there. Remember, in this podcast, we're talking about chords. The circle of fifths tells us which chord triads are available to us in each key. So if we're composing our song in the key of C, we can easily see which chords we can include in our song. Here's how. Looking at C on the circle, well, we know that in the key of C major, the chord C major will be one of the chords available. Now we look at the 2 chords either side of C on the circle. These are F and G. So F, C and G will be the major chords available in the key of C. Carrying on round the circle in a clockwise direction, the next 3 chords, D, A and E, will give us all the minor chords available in the key of C. The 7th and final available chord in the key of C is the diminished chord of B. So if we now lay those out in pitch order rather than in the order they appear on the circle of fifths, the chords available to us in the key of C are C major, D minor, E minor, F major, G major, A minor, and B diminished. The reason that these are the chords available to us is that they are made up of notes which exist in the C major scale. You'll notice there are no sharps or flats in any of these chords, as there are no sharps or flats in the scale of C major. If we look at another key, say The next key around the circle, G major. We simply use the same method to find out which chords are available to us in G major as well. Firstly, the major chords, which are found by taking the G major chord and the two chords surrounding it on the circle, C major and D major. Then, carrying on around the circle, we get the three minor chords, A minor, E minor and B minor. And finally, the diminished chord of F sharp. Again, all these chords are made up of notes which exist in the G major scale. You can use the same method to find the chords available in whichever key you want to write your song in. So the circle of fifths helps you work out the palette of chords you have to work with in your song. But the circle's usefulness doesn't end there either. Remember, the circle of fifths is laid out in such a way that it shows us the relationship between different keys. This is especially useful if you want to transpose your song into another key. Say you've just finished writing your song in the key of C. Along come your vocal artists, and you suddenly discover that C is too low for them. They would have preferred it if you had written your song in the key of E. You hold your head in frustration. Oof, all that careful chord work you did, and now you have to throw the whole lot away and start again in a new key. Well, don't worry. You'll not be burning the midnight oil on this one after all, as the circle of fifths gives you a time-saving way of easily transposing the chords you have already written. C is at the 12 o'clock position on the circle, and E is on the 4 o'clock position. That means, to go from C to E, we have moved clockwise around the circle by 4 steps. Each chord in your transposed song, therefore, does exactly the same. An F chord, for example, would become A, as A is 4 steps clockwise around the circle from F. A G chord would become B, and so on. Exactly the same is true if you move to a key that is anti-clockwise around the circle from your original key. Simply count the distance between the keys and shift all the chords in the song by the same distance. Voila! In 5 minutes, you've transposed all the chords in your song. Talking of transposition, what about changing key in the middle of your song to add interest and variety to your composition? Well, there are 2 ways in which the circle can help you modulate between different keys in your song. Different keys are said to be closely related if their respective scales share many of the same notes. The more notes shared by each scale, the closer they're related. Each major key has what is known as a relative minor key associated with it. That is, a minor key that shares all the same notes in its scale as the major key. Therefore, the closest key to any major key is its relative minor. For example, the key A minor shares all the same notes in its scale as C major. There are no sharps or flats in either key. Therefore, A minor is C major's relative minor. On the circle of fifths, each key's relative minor is written with a small letter on the inside of the circle in the same position as the major key. So C major is written with a capital C at the 12 o'clock position on the outside of the circle, and A minor is written with a small a at the 12 o'clock position on the inside of the circle. So why is this important for us as songwriters? Because it means that modulating between C major and A minor is very easy to do in a song, as each key contains the same chords, so we can flit back and forth between the 2 keys with ease. I can play my tune in C major, and then repeat it easily in A minor, without having to do too much work to link the 2 parts of the melody together. But what about something a little more complicated? Could you start off your song in C major and at some point modulate to another major key such as G major? Well, the answer is of course yes, with a little work. How much work it takes depends on how closely the two keys you are working in are related to each other, and the circle of fifths tells us exactly that. C and G are adjacent to each other on the circle, therefore they are said to be closely related. Their scales share many of the same notes. In fact, because the key of G only has one sharp in it, and C has no sharps in it, they share all the same notes apart from one, F sharp, which exists in the key of G but not in the key of C. In order to modulate cleanly and musically between keys in the middle of your song, at the moment of modulation you have to trick your audience's ear into thinking it could be in either key. We do this by a chord known as a pivot chord. A pivot chord is a chord that exists in both keys. By arriving at the pivot chord in your starting key and then using it as a pivot to take yourself off in a new direction into your new key, you can guide the audience's ear through the modulation into the new key. I go into exactly how to do this in more detail in the podcast extra, but for now I'm going to show you how to use the circle of fifths to find these pivot chords. This is done by using the circle to find which chords are available in your starting key, as we described before, then finding which chords are available in your new key, and seeing which chords are identical in both keys. It is easy to modulate between closely related keys, as closely related keys will have more chords that exist in both keys, i.e. you have more flexibility in choosing on which chord to pivot into your new key. So as we discovered before, in the key of C, the chords available to us are C major, D minor, E minor, F major, G major, A minor, and B diminished. In the key of G, the chords available to us are G major, A minor, B minor, C major, D major, E minor, and F sharp diminished. Matching these chords together, we find that the following chords exist in both keys: C major, E minor, G major, and A minor. Therefore, any of these chords could be used as your pivot chord. In the following example, I'm going to use the A minor chord as my pivot chord. Again, I go into this in more detail in the podcast extra, but just to give you a taster of the end result, here is my little tune which starts off in C major and modulates to G major.
Here we are in the key of C, but is that where we really want to be? To add a touch of variety, perhaps we could modulate to G. In order to do it musically and to lead the ear into the new key, we pivot on A minor, this is he, as he leads us through D7th into G. Now we need a little melody to confirm that we're in the key of G. Then we return to the tune we played in C, only now we're in the key of G.
This video is part of a larger podcast about chords and harmonies called Striking a Chord. The full podcast can be heard at www.themobilestudio.net/podcast and go to podcast number 1. You can also gain free access to the podcast extra material by going to this webpage and clicking on the subscribe button on the right-hand side of the page.